Today we're going to do a short exercise on getting the NASA Goddard Institute for Space Studies, or GISS, G-I-S-S, their surface temperature analysis into RStudio. This is the data that you often see on global warming plots, temperature plots through time. And there's a variety of ways to get this. There's many plots that they have up here, but we're going to go ahead and come down and look at what are called the tables of global and hemispheric monthly means and zonal annual means. So we're going to get a global mean, a hemispheric monthly mean, and a zonal mean. So we're going to focus on this one right here, the zonal annual mean. So this is 1880 to present, updated through the most recent complete year. They have a CSV file that you can click on and it'll download, but you can also read this thing directly from the internet. So if you right click on it and you copy the link address, you can go straight to R, and we'll go ahead and just save this here. So this is, I'm just going to put a comment here, reading in zonal mean times series from NASA GISS. Okay, so here we're going to make this object. Just going to call it NASA temps read.csv. The quotes there. Okay, and this should come in, I think, rather nicely. We'll go ahead and read this. And we'll do a head. NASA temp. Great. So here's year. Here's the global mean, the northern hemisphere mean, the southern hemisphere mean, and then these are all these different zonal bands. So this is average from 24 north to 90 north. 24. This is latitude. 24 north latitude to 90 north latitude. 24 south to 24 north. So this is around the equator. So all these different zones have been averaged for us. So let's go ahead and grab this here. We can just take, since this is just yearly data, we're just going to call this NASA year. And this is just NASA temp, first column. Yep, there's all our years. Okay, and let's go ahead now and plot NASA year, and let's go ahead and add first the global line. So that's going to be NASA temp column 2. And we'll do type equals L, Y limit -3 to 3. So these are temperature anomalies. So this is different from normal. So our Y lab is going to be our temp anomaly in Celsius, and our X lab is going to be year. And let's put a main title on here. Surface temperature anomaly relative to 1951 through 1980 average. So what they did is they came in and they took an average for the whole globe from 1951 to 1980, and then subtracted that from all these values, and then they did it for every hemisphere and then for the zone. So let's go ahead and put this plot together. Oh, an error somewhere here. Aha, here it is. This should be a comma. Okay, so here's our temperature anomaly. So you'll see that from 1951 to 1980, Right in here, we're really close to 0, so that's our 0 time. So you'll see that times previous to that, the global average was lower than this time period between 1951 and 1980, and since then, we're higher than that by almost a degree on average, something like that. But that's going to be different for the northern hemisphere and the southern hemisphere, so we're going to look at that. The lines. Look at NASA year. That's the third column. So if we look back up at so here's the first column, what's year. Second column's globe. The third column's the northern hemisphere. Type equals, actually it's going to be a line anyway, so let's just do color equals red. So I'm going to throw on the northern hemisphere. Okay, so the northern hemisphere is looks like a little higher than the southern hemisphere, or maybe than the globe. We can just copy and paste this. So this will be the southern hemisphere. Let's go ahead and make this blue. Throw that line on there. Southern hemisphere. Okay, looks like they're pretty much in sync here, but now we're getting a divergence here later on. And let's add another one. Let's copy and paste this. And we're going to look at the 64 to 90 north, just for fun. So we're going to look at, here it is, 64 to 90 north. So that is the 1, 2, 3, 4, 5, 6, 7, 8th column. So this is average everything from 64 north to 90 north. 64 north to 90 north. All right, let's take a look at that. So that's pretty far up there, up in the poles. Three, four, that's the 8th one. Really, it's up in the Arctic. And we'll make this green. There it is. So it's really changing quite a bit more than the rest of the planet. And maybe for fun, we'll add the southern poles. What that would be 64 south to 90 south. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, the 15th one. What color should we make that? How would we make that? Pink? Maybe pink will work. There it is. There's pink. Kind of hard to see. But there it is. It looks like it was cool while it was warm here. And hasn't warmed up quite as much. A lot of the warming up in the northern pole. Okay. So here we go. Let's go ahead and make a legend. We'll put it in the top left. And our legend will be, what is this going to be? The first one is our global temp anomaly. Actually, we can just call this global. And then we'll call the next one northern hemisphere, the next one southern hemisphere. And then we'll have 64 to 90, put this in quotes, 64 north to 90 north. And then we'll have 64 south to 90 south. Put the colors in here. The first color was black, and then was red, and then was blue, and then was green, and then was pink. And our line weight equals 1. So our legend is just saying, where do you want the legend? It's going to be in the top left. What's the text you want with each category? Well, we did global line, northern hemisphere line, southern hemisphere, 64 to 90, 64 north to 90 north, and 64 south to 90 south. And the colors that those lines are that correspond to the colors that we gave these lines, which are, well, the default was black here, then red, blue, green, pink. So black, red, blue, green, pink. Line weight equals 1, and you should see that. Oh, what did I do here? Oh, I forgot to close this thing, so this is going to error out. Yeah, oh, yeah, it didn't quite work. So I'm just going to grab all of this, run it again. There we go. So there are the lines. Okay, so these are zonal averages. So this is a nice table you can look at quick, but if you want to look at gridded data for this anomaly, it's a little bit different, and that's something else that we'll look at in a different video.